In this lesson, we'll be working on creating the tab shape. Up to this point, we've been starting our sketches on the default front, top, and right reference planes that are included with each part template. In addition to these, SOLIDWORKS includes a reference geometry tool that allows you to add reference planes. However, SOLIDWORKS conveniently allows you to use faces of the model to define the sketch plane. And when you have a face of the model, such as this face here, it's not necessary to create additional planes. To begin a sketch on this face of the model, I can simply click on the face and select the Sketch icon from the pop-up here. Alternatively, I can switch over to the Sketch tab of the Command toolbar, and when I click the New Sketch icon from here, SOLIDWORKS asks me to choose a plane, a planar face, or an edge on which to create a sketch for the entity. So, I'll click this face here, and when I do, SOLIDWORKS puts us into Edit Sketch mode, as you can see from the status bar and these icons up here, and Sketch 2 is added to the Feature Manager tree. Since SOLIDWORKS didn't automatically rotate us to look normal to the sketch plane, I'll press the space bar on the keyboard and double-click the Normal to View orientation so that I'm looking straight onto the sketch plane. Although the face of this model is a small rectangular face, it's really defining an infinite plane that we can sketch on. What I mean is, when I click the Rectangle tool and define a sketch anywhere in space, if I rotate the model a little bit, you can see that we're actually sketching on an infinite reference plane, which is defined by this face. I'll look normal to the sketch plane again by pressing the space bar and selecting the Normal to View. To get rid of this geometry, I'll box select it and press Delete on the keyboard. Now, to create the tab shape, I'll start by using the Line tool, which I'll activate using the shortcut toolbar. I'll begin the line so that the endpoint is coincident with this top edge of the model. Paying attention to the number next to my pointer, I'll make sure it's relatively close to the final size. Again, it doesn't have to be perfect. We'll use dimensions to define the actual size a little later. I'll click again to create the endpoint, and next we're going to create an arc that connects this line segment to another angled line segment. Now SOLIDWORKS does include an arc tool, as you can see here on the Sketch toolbar, but I'd like to show you a nice shortcut that you may find very convenient. With the Line tool still active, SOLIDWORKS provides a way to quickly switch to the arc tool simply by moving the cursor close to the end point of the line, and without clicking anything, simply moving the cursor away from the end point. Now you can see that the arc tool becomes active, and I can move this arc from one side to the other. Notice that if I want the arc to go below the first line segment, I can simply bring my cursor back to the end point and move my pointer off in a different direction. I'll go ahead and sketch the arc that I want, and then all I have to do is click to define the end point of the arc. When I do, SOLIDWORKS automatically brings us back into the Line tool. This is really convenient for creating arcs quickly when you're sketching a chain of lines. I'll snap the end point of this line onto the top edge of the model, and when I do, you can see that there are actually two yellow flags that appear. The Coincident icon informs me that the endpoint is coincident with this top edge of the model, and a Tangent icon appears to let me know that this segment will be tangent to the arc that we created. Finally, I'll close this profile by bringing my pointer back to the first endpoint. For the Extrude feature, we'll want this to be a closed profile. I'll press the Escape key to get back to the selection arrow, and you can see the green flags which identify the automatic relations that were added as we sketched. In case you don't see the tangent relations or these coincident relations, Keep in mind you can add these manually as well. Let me give you a quick reminder. I'll delete this relation flag by clicking on it and pressing delete on the keyboard. Now you can see that the line is no longer tangent to the arc. If an automatic relation was not created, you can add it manually by selecting the arc and control-selecting the line and choosing the tangent relation from the pop-up or from the property manager. Next, we'll fully define the sketch using dimensions. To launch the Smart Dimension tool, I'll press the S key from the keyboard, and I'll begin by giving the tab a height dimension. I'll choose this line segment and the arc, and notice that SOLIDWORKS snaps the dimension onto the center point of the arc. I'll click again to place the dimension and type in 50 millimeters. In case you want this dimension to attach to the arc itself, rather than the center point, you can actually move this endpoint of the dimension just by clicking and dragging, and you can see that SOLIDWORKS snaps into the new position. For our example, I'm going to keep the endpoint onto the center point of the arc. Next, I'll give the arc a radius value. I'll click on it, type in 25 millimeters, and press Enter on the keyboard. Moving on, I'll create an angle dimension between this angled line and this horizontal line, and type in 75 degrees. I'll repeat this process for the opposing line segments and produce an angle of 75 degrees. At this point, notice that most of the geometry is still blue. If it's unclear which dimensions you still have to add in order for the sketch to become fully defined, I always recommend pressing Escape on the keyboard to get back to your selection arrow and then clicking to move the geometry that's still underdefined. I recommend clicking on a combination of points and segments to see what you're still able to move. In this case, our geometry is still free to move from side to side. The design intent of this part calls for the tab to always stay centered with respect to the base extrude geometry. So how do we accomplish this? Well, one approach would be to utilize dimensions. We know that the overall length of the rectangle is 150 millimeters, so we can create a dimension of 75 millimeters from the edge to the center point of the arc. Although this would be a sound approach, I would prefer to use geometric relations to ensure that the tab always stays centered, in case our base geometry ever changes down the road. To do this, I'll create a center line to use as a reference to make sure that this tab shape stays centered directly above the origin of the part. Notice next to the line tool here in the toolbar, there's actually a drop-down arrow where I can choose from a line or a center line. I'll activate the Center Line tool, and to begin, I'll make sure that the pointer shows the yellow flag when I'm on the center point of the arc, indicating the geometric relation will be added. And for the next endpoint, I'll select the origin of the base part. Again, I'll make sure that the yellow flag appears for the geometric relation. To complete the center line, I can either double-click or press Escape to get back to my selection arrow. With the center line added, the geometry is still free to move from side to side, but if I add a geometric relation on the center line by clicking on it, I can choose to make this center line vertical. When I do, the geometry turns black and fully defined. By making the center line vertical, I can be sure that the arc is always directly vertical with the origin. Now at this point, the sketch is fully defined, and we can move on to create the feature. But before I do so, I'd like to show you a couple more tools in the sketch environment. In this example, I used 2 angular dimensions. But perhaps I want these segments to always have the same angle. If the design ever needs to change, under our current dimensioning scheme, I would have to change both dimensions manually. To incorporate a little bit of design intent, let me show you another approach. I'll click on this dimension to highlight it and press Delete on the keyboard. I'll press Escape to get back to my selection arrow, and at this point, you can see that this angle is now free to move. If I want to ensure that this line segment is always the same angle as this one approach is to use symmetry. I'll add a symmetric geometric relation by selecting this point here, holding down the Control key, selecting the center line, and with the Control button still pressed down, I'll select this endpoint here. With all three entities selected, SOLIDWORKS shows me that a symmetric relationship is possible. I'll click it from the Property Manager, and you can see this sketch turns black again. With this design intent, if I change this angular dimension once, you can see that both segments update to maintain the symmetric relationship. I'll switch this back to 75 degrees by double-clicking on it and clicking the green check. Next, let's move on and create the extruded boss. To do this, I'll switch to the Features toolbar and click the Extruded Boss Base tool. Whenever you're moving from the sketch environment on to create a 3D feature, I always recommend looking at an isometric view. You can rotate the part in the graphics area, or you can press the spacebar and double-click the isometric orientation from here. I recommend switching to an isometric view because it gives you a clear picture of which direction the extruded geometry is being added to. If I were to use the normal to view, you can see that it is difficult to tell what direction the arrow is facing. So I'll zoom out a little bit and rotate to give us a better perspective. Since the geometry is being added in the wrong direction for what we need here, I'll click the reverse direction icon here in the Property Manager, and since our first base extrude was using 15 millimeters, SOLIDWORKS remembered that value and had saved it here in the Property Manager for us. I showed you in the first lesson how the tab shape was extruded to the entire width of the part. Since we know the part is 100 millimeters, I can type in 100 millimeters for the dimension and press Enter. But what happens if the width of the base extrude were to change at some point? If you change the width of the base extrude to 125 millimeters, SOLIDWORKS wouldn't know to update this tab extrude, so you would end up with a 25 millimeter space on the side of the model. To incorporate some additional design intent, taking advantage of the parametric capabilities in SOLIDWORKS, another approach would be to use an end condition. Instead of blind, another common end condition is the Up to Surface option. When you choose Up to Surface, you can see this box highlighted in blue appear, asking you to choose a face or a plane. If I select this face here, SOLIDWORKS doesn't show you a value for the width of the extrude. It simply knows to always extrude up to this face here. This can be very useful, because if the original base feature were to ever change to a value other than the existing 100 millimeters, the extrusion width of the tab would also change to the new value automatically. For this example here, I'll switch back to use a blind end condition and enter 15 millimeters for the thickness. Taking this approach, I'll be able to show you a couple other features, such as the mirror feature, and talk about some other ideas of design intent to get you familiar with it. So at this point, I'll click the green check in the Property Manager to finish the tab feature.